Today, we will talk about history of AI. Artificial intelligence, AI, is a young discipline of 60 years, which is a set of sciences, theories, and techniques, including mathematical logic, statistics, probabilities, computational neurobiology, and computer science, that aims to imitate the cognitive abilities of a human being. Initiated in the breath of the Second World War, its developments are intimately linked to those of computing and have led computers to perform increasingly complex tasks, which could previously only be delegated to a human. However, this automation remains far from human intelligence in the strict sense, which makes the name open to criticism by some experts. The ultimate stage of their research, a strong AI, the ability to contextualize very different specialized problems in a totally autonomous way, is absolutely not comparable to current achievements, weak or moderate AIs, extremely efficient in their training field. The strong AI, which has only yet materialized in science fiction, would require advances in basic research, not just performance improvements, to be able to model the world as a whole. 1940 to 1960, birth of AI in the wake of cybernetics. The period between 1940 and 1960 was strongly marked by the conjunction of technological developments, of which the Second World War was an accelerator, and the desire to understand how to bring together the functioning of machines and organic beings. For Norbert Wiener, a pioneer in cybernetics, the aim was to unify mathematical theory, electronics, and automation as a whole theory of control and communication, both in animals and machines. Just before, the first mathematical and computer model of the biological neuron, formal neuron, was developed by Warren McCulloch and Walter Pitts as early as 1943. At the beginning of 1950, John von Neumann and Alan Turing did not create the term AI, but were the founding fathers of the technology behind it. They made the transition from computers to 19th century decimal logic, which thus dealt with values from 0 to 9, and machines to binary logic, which rely on Boolean algebra, dealing with more or less important chains of 0 or 1. The two researchers thus formalized the architecture of our contemporary computers and demonstrated that it was a universal machine, capable of executing what is programmed. Turing, on the other hand, raised the question of the possible intelligence of a machine for the first time in his famous 1950 Computing Machinery and Intelligence, and described a game of imitation, where a human should be able to distinguish in a teletype dialogue whether he is talking to a man or a machine. However controversial this article may be, this Turing test does not appear to qualify many experts. It will often be cited as being at the source of the questioning of the boundary between humans and machines. 1980 to 1990, Expert Systems. In 1968, Stanley Kubrick directed the film 2001: Space Odyssey, where a computer, HAL 9000, only one letter away from those of IBM, summarizes in itself the whole sum of ethical questions posed by AI. Will it represent a high level of sophistication, a good for humanity, or a danger? The impact of the film will naturally not be scientific, but it will contribute to popularizing the theme, just as the science fiction author Philip K. Dick, who will never cease to wonder if, one day, the machines will experience emotions. It was with the advent of the first microprocessors at the end of 1970 that AI took off again and entered the golden age of expert systems. The path was actually opened at MIT in 1965 with General Expert Systems specialized in molecular chemistry, and at Stanford University in 1972 with MYCIN, systems specialized in the diagnosis of blood diseases and prescription drugs. These systems were based on an inference engine, which was programmed to be a logical mirror of human reasoning. By entering data, the engine provided answers of a high level of expertise. The promises foresaw a massive development, but the craze will fall again at the end of 1980 or early 1990. The programming of such knowledge actually required a lot of effort, and from 200 to 300 rules, there was a black box effect where it was not clear how the machine reasoned. Development and maintenance thus became extremely problematic and, above all, faster, and in many other less complex and less expensive ways were possible. It should be recalled that in the 1990s, the term artificial intelligence had almost become taboo, and more modest variations had even entered university language, such as advanced computing. Since 2010, a new bloom based on massive data and new computing power. First of all, access to massive volumes of data. To be able to use algorithms for image classification and cat recognition, for example, it was previously necessary to carry out sampling yourself. Today, a simple search on Google can find millions. Then the discovery of the very high efficiency of computer graphics card processors accelerated the calculation of learning algorithms. The process is very iterative. It could take weeks before 2010 to process the entire sample. The computing power of these cards, capable of more than 1,000 billion transactions per second, has enabled considerable progress at a limited financial cost, less than 1,000 euros per card. This new technological equipment has enabled some significant public successes and has boosted funding. In 2011, Watson, IBM's Aya, will win the games against two Jeopardy champions. In 2012, Google X, Google's Search Lab, will be able to have an ad recognize cats on a video. More than 16,000 processors have been used for this last task, but the potential is extraordinary. A machine learns to distinguish something. In 2016, AlphaGo, Google's AI specialized in Go games, beat the European champion, Fan Hui, and the world champion, Lee Sedol, then herself, AlphaGo Zero. Let us specify that the game of Go has combinatorics much more important than chess, more than the number of particles in the universe, and that it is not possible to have such significant results in raw strength, as for Deep Blue in 1997. Among machine learning techniques, deep learning seems the most promising for a number of applications, including voice or image recognition. In 2003, Geoffrey Hinton, University of Toronto, Yoshua Bengio, University of Montreal, and Jan Lakin, University of New York, decided to start a research program to bring neural networks up to date. Experiments conducted simultaneously at Microsoft, Google, and IBM, with the help of the Toronto Laboratory in Hinton, showed that this type of learning succeeded in halving the error rates for speech recognition. Similar results were achieved by Hinton's image recognition team. What do you think of our video? Let me know in the comment section below. Before you go, please hit the like button and subscribe to my channel. Thanks for watching.